Hello my dear students, hope all are doing good. So today I want to discuss with you few questions from the chapter ray optics. So we will be discussing today some board questions. I will show you the question, send you the PDF file also along with this video where I have discussed the questions, giving the hint so that you can complete the answers. So let's move to question number 1. You can see here the question number 1 is, a beam of light converges at a point P. A concave lens of focal length 16 cm is placed in the path of this beam 12 cm from P. Draw a ray diagram and find the location of the point at which the beam would now converge. Means there is a beam of light. Let me draw here. You can see the first one is there is a beam of light. So I have to draw a beam of light. So this is your question number 1. So this is suppose a straight line, and I suppose that this is a point P where the beam of light is converging. Let me draw a dotted line. You can use a scale to draw. So let's say it is converging at this particular point. So what happened, according to this question, we will place a concave lens now at a distance of 12 cm from P. Means we will place the concave lens here. Suppose this is placed here, concave lens. And from P this distance is my 12 cm. Okay, so this point P acts as an object for the concave lens, and we have to find the image distance. Because f is equals to focal length is given 16 cm, we came to the object distance is 12 cm. Let us assume this to be O. We know that the distance from the object, no doubt it is not a real object, it's a virtual object, to the lens is the object distance, but since it is on the right hand side, so I have considered it to be positive. So now by using lens formula 1 by f equals to 1 by v minus 1 by u, I can write from here 1 by v is equals to 1 by f plus 1 by u. So I can write 1 by 12 plus 1 by 16. So LCM what will happen, 16 and 12, if I find out the LCM, I think I will get 4 4s are 3s are 16 into 3s are 48. So 48 will be the LCM. Then numerator, what will happen in the numerator, I will write 4 plus, I think, let me check what I can write. Just tell me what will be the answer. I think you have done it. So I can write from here. One more thing I forgot to, I have made something mistake. So this will be minus, because focal length of a concave lens is minus. So this will be minus. So minus, this will be minus 4. I think yes, 16 is my, sorry, so this will not be minus, this will be my minus. So I can write plus 4 minus 3. So from here I will get 1 by 48. Therefore v will be equals to 48. Now you see this value came in positive number. So if it came in positive number, that means what, where will be this 48 cm? I have to think 48 will be somewhere here. So at this particular point, from here you do one thing, join this line. Sorry, this one you consider it to be I. So from here you join this. So this will be the I, that is the image position. I hope you have understood. So like this you have to solve this sum. Done. So now move to the question number 2. If I move to question number 2, it's a long question, but it is little bit, it came in 2018 and many students have not done the question, thinking that it is too tough. The question you see, a symmetric biconvex lens of radius of curvature r and made of a glass of refractive index 1.5 is placed on a layer of liquid placed on the top of a plane mirror as shown. The diagram is given here. Then an optical needle with its tip on the principal axis of the lens is moved along the axis until its real inverted image coincides with the needle itself. The distance of the needle from the lens is measured to be x. On removing the liquid layer and repeating the experiment, the distance is found to be y. obtain the refractive index of the liquid in terms of x and y. Okay, so we have to solve this. Means the question figure, I am going to draw it again. So this is a plane mirror. You can see this is a plane mirror. At the top of the plane mirror, you have given a liquid drop. Means water droplet is given, and after giving the water droplet, you have placed a convex lens here. The question is, the meaning is that now after that, what you have done from here, this is the axis line or not? Read the question again when I give you. So this is the axis, and there is, according to question, there is a needle, and a needle is moved here and there. Means from here to there, it is moved. When it is moved, it is observed that at a particular distance, both this and another one you will get it, which is the image dotted line I have to give. So they will coincide. It's okay. In that case, the distance of this particular needle from the lens is measured to be x. Okay, with the liquid and everything. Now what I have done, next step, we will remove this liquid. Means the water droplet that is given here is removed. We have made it only the plane mirror, then kept the lens, then calculated. In that case, if I do it, I got that the distance is y. So I have to find out the refractive index of the material of the what material of the liquid in terms of x and y. Now see, if the object and the images, they are coinciding at a point, I can assume that I'm writing focal length. I'm writing focal length of the equiconvex. Equiconvex means the normal convex lens, equiconvex lens, and water. Means both are in contact with each other or not? Water. That is f, we will assume it to be x. Done. So this is my first assumption that I have to consider. Move on to next. Then if the water is not there, then the focal length of equiconvex length, only the convex lens will come. Then that one, if I write f, it is y. Now I will not write y here, I will write f1 will be equals to y. Means this is the liquid will be here. So liquid is my second lens, this is my first lens. Means the first lens, only the lens. So only the lens, it is y. With this, it is what? With this, it is, I can say, focal length of the equiconvex lens and water. I hope you remember we have studied focal length of the combination of two thin lenses. So here, this lens is a one lens, second lens, the water that will be here, will be my second lens, we have to assume. So if I don't have this part, then it is only one lens, means it is f1. If I have the water only, then this is f2. Done. Then together, what is this? Together it is f. So what I can write, and let f2 be focal length of water. Now you might say that, ma'am, if I remove this, it will not be a straight. Yes, it will be a straight. I'm not talking about the straight now. Because, see, when I have placed the lens above it, so it appears like it is a lens. So we are talking about that lens, f2 I consider. So we know that by combination, f will be equals to 1 by f1 plus 1 by f2. So I hope you can calculate from here the f2. So what we will do now? So 1 by f2 will be equals to 1 by f minus 1 by f1. Now substitute the values. It will be 1 by y or x. X I have considered minus 1 by y. So I will take x, y LCM. So it will be y minus x. Therefore, f2 will be equals to xy divided by y minus x. So this is the focal length of what? The water lens. In the figure, you might have observed that the water lens with the plane mirror. So this is a plane mirror. This is a convex lens above it. So this is a water lens or not? This is water lens. This water lens along with this plane mirror, is it behaving like a plano-concave lens? Yes, it is behaving, because if I take this part, this is my water, this part is my water, this is my water, and this is my plane mirror. So this is a what? Plano-concave lens. And that is plano-concave lens means it is water plano-concave lens. in which the radius of R1 will be minus of R, because I have to consider it to be minus R. And the radius R2 will be what? Infinity, because it is plano concave. I told you in the last class that if it is convex, plano convex, this one will be plus, R2 will be always infinity. Then what will be by Lensmaker formula? F2 will be equals to, I hope it is in this way, then mu minus 1 into 1 by R1 minus 1 by R2. So F2 already we got this. So I can write from here y minus x divided by xy is equals to mu minus 1 into 1 by minus of R. Hope it is okay. Infinity I am not going to write. So from here I can write mu minus 1 is equals to, can I write this as x minus y divided by xy into R? Yes, I can write, because it is y minus x minus if it moves. So I have written x minus y. So refractive index is asked to calculate. It will be 1 plus x minus y by xy into R. So this is the expression for the refractive index. Hope it is okay. So next we will move to question number 3. Let's read the question. Question number 3. What is this question? A ray of light, you can see ray of light falls on a transparent, what? Falls on a transparent sphere with concentric, or with center C as shown in the figure. The ray emerges. When the ray will emerge, how the ray will emerge? The ray will emerge as from the sphere parallel to the line AB. Means this is the line, sorry, it is AB. It is emerging parallel. Let me check the question again. It is parallel to the line. What I said, parallel to the line AB. Done. Then find the angle of refraction at A if the refractive index of the material of the sphere is √3. It is very easy. Why? You see, if I use the Snell's law at this particular sphere, Snell's law, this is angle of incidence, I will get the angle of refraction here. So by Snell's law, can I write mu is equals to sine of I divided by sine of R? Yes, I can easily write. But it is given that mu is √3 in the question. Sine I is sine of 60 divided by what? Sine of R. We have to calculate R only now. So if I have to calculate R, I can write sine R will be equals to, sine 60 means √3 by 2 divided by √3. So this will cancel out. It will be half. So R will be equals to 30 degree. So this will be my answer. So this is very easy and to solve. So all these questions, whatever I will be discussing today, is from board question. So now move to question number 4. I hope the question number 4 I don't have to do also if it is easy. Is, let's see, I will give the hint. Two thin lenses of power, this and this, minus 4 and 2, are placed in contact coaxially. Means I can write power P1 equals to minus 4D. I can write power P2 equals to twice of D. I hope you can calculate from here. F1 will be 1 by P1 and F2 will be equals to 1 by P2. You have to find the focal length of the combination. We know focal length of the combination is 1 by F1 plus 1 by F2. So substitute from there, you will get the answer, I hope. So this is how you have to calculate question number 4. I'm not going to do that. Please complete the question. Next one is also very easy. An object is kept in front of a concave mirror of focal length 15 centimeter. Means F is equals to 15 centimeter. It's a concave mirror. So it will be minus. Concave mirror is this one. I already said that it is not there. Mirror is not there in the syllabus, but if we have to do questions related to some combination, there is a possibility that you might get. So this is a concave, means focal length is negative. The image formed is real and 3 times the size, means V if I write, it is 3 times the size of the object, means not V, H dash if I write, it will be 3 of H. Real image, or I can write it is a real image, M equals to H dash by H is equals to minus V by U. I hope you remember that you have studied. H dash is thrice of H divided by H, or equals to minus V by U, means magnification. Done? Yes or no? If you don't write this part also directly, you can write M is equals to 3 here. But since it is a real image, So I can write from here m equals to minus 3. So you write from here minus v by u equals to minus 3. So v will be equals to twice of u. It is okay, easily. The same thing I have written. But in terms of height, you have to calculate the object distance. How to calculate? 1 by f equals to 1 by v plus 1 by u. 1 by v is 1 by twice of u plus 1 by u. So this is 1 by minus of 15. Solve it, you will get the answer. Hope it is okay. Then move to question number 6. The question number 6 is little bit of some things are there I have discussed. I hope you can do it. A bulb is placed at the bottom of a tank containing water to a depth of 80 centimeter. Find out the area of the surface of water through which the light from the bulb can emerge. Take the value of the refractive index to be a 4 by 3. So this is a tank. At the bottom of the tank we have a bulb. This is a source. I can say bulb. So what happened? Up to its water is there. And I hope you remember I have taught you in this way. And if it has to come out, so it will be total internal reflection will be there. So this will be my IC. So here also I will get my IC here. This depth is given. Water depth is 80 centimeter. Then I think you can calculate this distance. That is the radius. It will be a hemisphere shape. So if I came to know about this, I think I can calculate using the formula pi r square. It is okay. So now you have to calculate this part. How to calculate this? If this is IC, then obviously this will be the IC. So if I know this distance I know, what concept I can use? I can use the concept of tan theta. Means tan of IC will be equals to perpendicular. Perpendicular means suppose this is A, this is my B, that is AB divided by AO. Done. AO is my 80. AB I have to calculate. IC I don't know. But IC how can I calculate? Sine of IC is equals to 1 by mu. So use from here. Find the value of 10. Use it here. You calculate this. So this is the radius. Substitute it. You will get the answer. Hope I think you can do, because similar type of question I have done in the class. Let's move to the question number 7 now. Sorry. See, it is also very easy, similar question I have discussed. You are given 3 lenses of power 0.5D, 4D and 10D to design a telescope. Which lenses should be used as objective and eyepiece? I hope you remember, if it is a telescope, the objective lens should have large focal length and the eyepiece lens should have what? Less focal length. And the difference is more. If I take a compound microscope, the difference is less. But if I take a telescope, the difference between the focal length is large. So obviously without doing also I can say, since the power is more, focal length will be less. Since the power is less, focal length. So this one will be the objective, this one will be the eyepiece. Justify your answer. You have to write that since power a focal length is required for a telescope to make an objective lens is large. So yet one you use, why is the aperture of the objective lens preferred to be large? What is the reason? Because if we have more aperture, the resolving power will be high. So that is, it will gather more power to get a bright image. See, if the lens is this much bigger, I am drawing another one. If the lens is bigger, means the aperture is large. What will happen? It will accommodate more light. So that it can form a bright image here. If instead I have taken a small lens, the amount of light that it will hold or gather will be less. So for that reason, we used to have a large aperture. Next one. Array PQ incident on the refracting phase BA is refracted by the prism BAC as shown and emerges from the other side AC as RS. Done. Such that AQ equals to RQ. AQ is equals to RQ means what? If these two are equal, this angle must be same. So if these angles are same, it is done. Now the question is, if the angle is of the prism is n equals to 1, calculate the value of theta. Theta is the deviation angle now. So you have to calculate the deviation angle from here. I hope similar question we have done in the class. you can do that. Okay, that's all for today's class. Hope you can do the rest 3 questions by yourself. Thank you and have a nice day ahead.